Let's take a look on this. Marginal product of labor. Okay, this is very important. Try to memorize it. Okay, for me, it's not that important to memorize it. Understand is very important. So you don't have to worry too much on that. Okay, at least you understand the concept, so you know that easily. You know that what's the marginal product and so on, the symbols and the formulas and so everything. Okay, marginal product of labor. Okay, which means it's a changes in the product over changes in the labor. Remember that. Okay, so changes in the product. Okay, changes in the product over changes in the labor. Okay, so that we call is the marginal product labor. Okay, it will be like you see the triangle. This triangle indicate as changes. Always remember whenever you look at the triangle, you just remember that this means that changes, perubahan. Perubahan pada Q means is the changes in the production of Q over changes in the labor. Okay, changes in the labor. Okay, don't substitute directly, guys. You just find that the changes maybe right after or right before. Okay, you find according to the questions what the question require for. So based on that, you can able to fix that the changes. Okay. Assume that the input and output are continuously or infinitesimally divisible, okay, rather than the being measured in the discrete units. Okay, then the marginal products of the labor would be like this, same exactly like this. This is a partial derivative, guys. This symbol not a derivative. Remember, it's not a d, the one you're using in the differential equation. This is a PDE, PDE. Excuse me. Partial differential equation. So MP marginal product equal to changes in Q over changes in L. So this is a partial derivative symbol. Partial derivative Q over partial derivative L. Okay. So since this is a short run, so we just fix that the Q equal to L and K bar. K bar. So bar is actually the on the top the bar we call as a K bar. So K is a fixed and labor is changes. We call a variable factor. The L is we call a variable factor. Okay. I always just remind you the same words again and again because you can be familiar with those terms. So that's why I just keep repeating that the things so that you can understand the words and the symbols. Okay, it's very good for you to remember. Okay, take a look at this example. Okay, let's consider the following production function. Okay, so given that the Q equal to 8k power of half times L power of half. Okay, so this is one of that Cobb-Douglas function as well. Okay, this we call one of the Cobb-Douglas function. So we go in deeper later, the Cobb-Douglas function, but you just look into it this level, the production function. It's just an example anyway. Okay, we're going to calculate the marginal products. Okay, as I said earlier, the marginal product is the changes in the Q over the changes in the L. So we know the Q now. Okay, they already know that the function, the production function, we already know. Okay, all right, now we're going to calculate that marginal production. Okay, the marginal product. So we use this equation 8k power of half times L power of half. Again, the K stands for capital and L stands for labor. So look at the formula. The formula is a partial derivative. So it doesn't mean the partial derivative. You only need to look into that the L. So this L is subject to differentiate. Don't differentiate the Q, or don't differentiate the K. Remember, whatever the down there, that has to be subject to differentiate. Okay, so even though the Q function is L and K, but the marginal product, they wanted to differentiate only the L. Okay, so the MP is equal to 8k 1 over 2 times. If you differentiate that, so you get you bring that the half in front of the L, is 1 over 2 L, and then half minus 1, it become minus half. Okay, so I'm sure you learned that the calculus, basic calculus before. So I think this shouldn't be a problem for you, huh? So don't do anything with the K, just only the L, because the formula is changes in K over changes in L. So it's a partial derivative. You just only look into the L. So the marginal product will be, you can split into the two sections, which is one is for total product L equal to 8LK. This unchanged. You just copy this, you paste here. And then the marginal product, remember that 1 over 2 L minus 1 over 2, right? So you need to simplify it. You just simplify with the what do you call the coefficient value here. Okay, the coefficient value of the K is 8. So you just cancel 1 times 2 is 2, 4 times 2 is 8. So you get 4 L power of minus half. So you copy this and paste this. So you simplified with that, the fraction with that, the one is subject, the one you just differentiated with using that partial derivative. Okay, so the marginal product will be 4 times L power of minus half. So this is that example how you need to do in that problem. Any question, guys? Up to here. Any question? Clear? All right. Now, take a look on the productions of the output elasticity of labor. This is very interesting. Same things. The elasticity of the output with the respect to the labor, measure the percentage change in the output for 1% change in the labor input, holding the capital input constants. Okay, so the elasticity formula is this, elasticity E. Okay, these are for the labor equal to partial derivative Q over partial derivative L times L over Q. Okay, and now as we know that the partial derivative of Q and over the partial derivative of L, so we know that this represent the marginal product. Okay, so that you can substitute the this formula with that marginal product times L over Q. Okay, so you can simplify it in this way. So these are two ways you can write. One is in the partial derivative forms, or you can substitute with that partial derivative of Q over partial derivative of L with that marginal product. Okay, times L over Q.